Hi, and welcome to a quick little tutorial on how to draw an ideal plot for a sensor. We're going to assume that we have a little pressure sensor, and this is what we call a differential pressure sensor. It takes two pressure inputs, and it gives us the difference in pressure between them. So in this case, we'll have 0 to 10 psi. What comes out of our sensor, our output, is going to be voltage. In this case, it's going to be 0 to 5 volts. I also want to assume that we have a linear system, which means that the relationship between input and output obeys y equals mx plus b, also known as a straight line. Now I've already drawn some axes for us, so let's zoom in and start adding things to these axes. First I'm going to do my x-axis, which happens to be my input axis. In this case I have pressure, and really this is my delta pressure, and that's going to be in psi. And then on my y-axis, this is always my output axis. In this case, I have voltage, and that's going to be in volts. Now I can start adding some numbers to this. I know that my pressure goes from 0 to 10 psi, so I'm going to come down and I'm going to go from 0 to out here at 10 psi, and I know my voltage is going to go also from 0 volts up to 5 volts. Now just for convenience, while we're working on the iPad here, I'm just going to draw in a couple of lines just so that I sort of can see this area that we refer to as our design space. So everything in this area is going to be the area that we could have a sensor input and output. And we know that this is linear. We know that this value up here and this value down here must exist on that line. So I'm going to create my nice little line from 0, 0 to 5, 10. And that's it. That's all we need for a common sensor. Now remember that this is a design line, so this comes from our first principle calculations. And there's a few stops along the way here that I just want to point out, some important, interesting things. First, this value of 5 up at the top has a special name. This is our full scale, all the way up, output, FSO, and that would be 5 volts. We also have a special name for this white dashed line over here. This is our full scale range, and in this case, this is 10 psi. And while we're talking about some important things that we could show on a plot, we don't have to show any of these, but important things that we could find on this plot, we can also find this difference here, this distance is 0 to 10, and we call this our range. And in this case, since this is our input range, and we express this as a range, so 0 to 10 psi. And we have something else that we know. We have what we call our span. And the span is the difference in our range. So 0 to 10, our difference is 10 psi. We have the same thing for our output. So we have our output range, and our range for our output is 5 volts. Our span for our output is also going to be 5 volts. Whoops, I should draw this in here correctly. Our range is 2 values, not 1. Our range is 0 to 5 volts. One last thing we could talk about is this line. This line follows y equals mx plus b. There's 2 special names in here too. This b value we call a null offset, so how far up the y-axis we come. So when we're at 0 psi, what is that value that we get out? The other special thing we have here is m, which is our slope, and every time you see slope, you should think sensitivity. In this case, we can easily find our sensitivity. That would be just the simple slope formula that is rise over run, or our 5 volts divided by our 10 psi. And this is an important set of information and really, honestly, everything we need to know to characterize this